Alright, so tonight we're going to take some notes on the start of Unit 2 and then do a couple examples. So, some things, first this section is called recursively defined sequence terms. So, some notes that we need to, some terms we need to be familiar with. First one is sequence. So, a sequence is an ordered list of numbers. And let's just spell that out. So, for example, a sequence might be 2, 5, 8, 11. So, term is each individual number in the sequence. So, for our above example, we have that 8 is the third term. That's the third term. 2 would be the first term, and so on. You might be asked to find the fifth term. And when you do that, we'd have to look for the pattern, which we'll talk about. General term, we're going to call that the nth term, and we're going to denote it as U sub n. So that is U sub n. It's going to be our notation for the general term. So we might have to find the general term of that sequence. Alright. Recursive formula. So recursive formula is the formula that defines a sequence and you must specify your starting term. And I'm going to explain what I mean about that in a little bit. Alright, recursive rule. Actually, I'll do the example now. So the example for our starting term in our last sequence would be U sub 1 equals, and if we go back, our first term there is 2. So U sub 1 equals 2. Alright, and then the rule is going to be, it's going to define the nth term in relation to the previous term. That's going to be big, so we're going to be in relation to the previous term. We're going to call that previous term, so the nth term, remember, is U sub n. The previous term is going to be, write that in the blue, is going to be U sub n minus 1. So nth term was U sub n. If we go 1 before that, we would subtract 1. So U sub n minus 1 is going to be our previous term. So for an example, and I'm going to take up this space and I'm going to write this on my next page. So for our sequence, we have start with your starting term. There's 3 things that you're going to need. Start with your starting term. U sub 1 equals 2. This value is normally going to be 1. Sometimes it might be 0 if it's a word problem and we're looking at something specific. It also might be like 3 if we're given a table and the table starts at 3 and then the value underneath it is 2. And next we're going to write our rule. So I'm going to have U sub n equals, and remember we're always talking about it in terms of the previous term. So now we have to go back and we have to look at what the pattern is. So what's the pattern? My advice to you is to always start with look to see if you're adding or subtracting. So look to see what what we call our common difference is. So I always do my second term minus my first. And then I do my third minus my second to see if that's the same number. So 5 minus 2 is 3. 8 minus 5 is 3. If you want to, you can check 11 minus 8. But our rule here is that we are adding 3 to our previous term. So our previous term is u sub n minus 1. And then our rule is we add 3 each time. Our last step that we need for our recursive formula is that we have to give our conditional statement. So we have to say that n is going to be greater than or equal to 1 more than the starting value there. So since our starting value is 1 there, n has to be greater than or equal to 2. So, and we called that, it should be defined for us, our conditional statement. So for recursive formula, you need 3 things: your starting value, your formula, and then your conditional statement. And this conditional statement is going to be n is always going to be greater than or equal to 1 more than your starting term. Then starting, I want to say term, yeah, starting term. So if this was u sub 5 here, n would be greater than or equal to 6. So u sub 10, n would be greater than or equal to 11. The reason that we need this is because we're always looking at our previous term. So if we start at 1, we don't necessarily know that we have a previous term. So we have to make sure that we're always starting with 1 more than our previous term to be able to use our formula. All right. Arithmetic sequence, or arithmetic sequence. I'm just going to have to write this out. That is, if I can get it written out fast enough, it's when a constant is added to each term of the sequence to generate the next term. The sequence to generate the next term. This constant is going to be called our common difference. The common difference. Alright, so let's go back to our example and see if we are adding. You can also think of it as subtraction as well, but instead of saying subtraction, we're always just going to say adding a negative if it is subtraction. So let's go back to our example here. We are adding 3 each time, so this would actually be an example of an arithmetic sequence. And our common difference there would be 3, because that's what we're adding each time. So geometric sequence now, different colors so they do a little bit, you can tell which one they are, is when a constant is multiplied. To the next term, or let's say to each term, because it has to be true throughout the whole sequence, to each term of the sequence, to generate the next term. Now, what's going to be different is this constant is going to be called the common ratio. So if our sequence example wasn't adding, we would then look to see if it was multiplication. And we can also think of division as going with a geometric sequence, but again, we are only going to write them in terms of multiplication. Okay, so our next one is, let's look at our first example. We had example 1. So u sub n equals, let me make it a little bit bigger for us too. U sub n equals u sub n minus 1, and remember, this right here just means our previous term. Minus 100. And they tell us u sub 1 equals 23. And we should actually add n is going to be greater than or equal to 2. They should have that in there, but we can still figure out what it means there. So is this sequence arithmetic or geometric? So are we adding and subtracting, or are we multiplying and dividing? Because this is minus 100, this is going to be an arithmetic sequence because you are adding negative 100. Now they with the first 4 terms. So our first term is u sub 1 equals 23. So for our second term now, we're going to plug 23 into our previous term, our u sub n minus 1, and subtract 100. Put that in your calculator and you get negative 77. Now for our third term, now our previous term is negative 77. So that's going to go where our u sub n minus 1 is, and we get negative 77 minus 100 is negative 177. And then our fourth term is going to be the same pattern. So now we take negative 177, subtract 100, and we get negative 277. You can leave your 4 terms like this, or you can write it out as a sequence if that helps you. No, that one doesn't look like a 7. If that helps you see the pattern. And negative 277. Alright. Please try the u-try. So we have u sub n equals u sub n minus 1 times 4. U sub 1 is equal to 0, or to 1, and n is greater than or equal to 2. So at this point, hit pause, and then when you're done, hit unpause so you can check your answer. Is the sequence arithmetic or geometric? Explain. So this is going to be a geometric sequence because you are multiplying by 4. Find the first 4 terms, and you're going to get 1. 1 times 4 is 4. 4 times 4 is 16. And then multiply by 4 again, we get 24. Alright. Example 2. Concert Hall has 59 seats in row 1, 63 seats in row 2, 67 seats in row 3, and so on. The concert hall has 35 rows of seats. Write a recursive formula to find the number of seats in each row. Alright, so let's start there. I see I have some numbers. 59 in row 1, 63 in row 2, and 67 in row 3. So I'm going to actually make a table to get started. So row, that's a bad line. Let's try that again. Let's get a little fancy and actually use a line. I can't draw a straight line apparently. Row, and then the amount of seats. Alright, in row 1 I have 59 seats. In row 2 I have 63 seats. In row 3 I have 67 seats. Alright, so you might notice the pattern right now, and you might be able to figure out row 4 and row 5. I'm going to write the formula first, and then we can figure it out. So, for my formula, I have, so it's kind of like A. The recursive formula is A. I have my starting value. U sub 1 equals 59. Even if you have no idea what to do, you can get a point for doing your starting value. Alright, then I have U sub n equals my previous term, so U sub n minus 1. And now I need to know the pattern. So what am I adding, subtracting, or multiplying by each time? I can see that I am adding 4 each time, so that's going to be plus 4 then. And then I need my conditional statement, which is going to be n is greater than or equal to 1 more than 1, so 2. Alright, to answer B, I need to figure out how many rows are in seat 4. So there's a couple ways I can do this. I can add 4 to 67, or I can even use my formula. So U sub 4 equals 71. That tells me that row number 4 has 71 seats. Oh, did I jump a little ahead? Yep. So I added 4 to 67 to get 71. But what I didn't show was I could have done U sub 3 equals, nope, go back a second, U sub 4 equals my previous term, so U sub 4 minus 1 plus 4. Well, U sub 4 minus 1 is U sub 3 plus 4. So U sub 4 equals U sub 3 is 67 plus 4 is 71. You don't have to show all that work. You can just fill in 71 here and then write it as U sub 4 equals 71. Alright, and then which row has 95 seats? So now what we're saying is U sub what, or which n value, is going to have 95 seats. So at this point, I'd probably continue my table, and you can do that in your calculator, or you can just keep adding. 5 is going to be 75, 6 is going to be 79, and again, you don't have to write all of this down. You can just use your calculator and keep adding 4. 7 is going to be 83, 8 is going to be 87, and 9 is going to be 91, almost there, and then 10 is going to be 95. So we're going to write U sub 10 is going to be 95. So the 10th row will have 95 seats. Alright, before you go on to the second try this, I want to add one more problem to look at. Let's look at this sequence here. 200, 100, 50, and 25. Alright, so first thing I always do, because I'm lazy, is I see if subtraction works. Alright, so 100 minus 200. You always do your first term minus your second term. So 100 minus 200, negative 100. 50 minus 100, negative 50. 25 minus 50, negative 25. I don't have a common difference. So now I look for multiplication to see if it's going to be geometric. And you might already be doing all of this in your head, but sometimes it's going to get more tricky, so I want to show you a way that works every time. So now I'm going to look to see my common ratio. So in order to do this, I do my second term divided by my first term. 100 divided by 200 gives me 0.5. 50 divided by 100, 0.5. 25 divided by 50 is 0.5. So to write this, I'm going to write U sub n equals, now one thing that I didn't like about the first you try this, is multiplication we always want to write in front, so that way it doesn't get lost with our n minus 1. So we're going to have U sub n equals 0.5 times U sub n minus 1. We still need our starting value, U sub 1 equals 200. We need our conditional statement, n is greater than or equal to 2. And we need to name this as a geometric sequence. Alright, it's just an example of a division 1. So really you're dividing by 2, but we don't say that with sequences. Instead we say we're multiplying by 0.5. Okay, please give this a try. Hit pause and then unpause it to check your answer. So for A you should get 22 people. For B you should get 15 tables. And for C you should get U sub 1 equals 4. U sub n equals U sub n minus 1 plus 2. And n is greater than or equal to 2.